and you're going to simplify, so we get Chapter 5, 144. Find the coordinates for all the relative maxima, relative minima, and points of inflection for the function f of x equals x squared minus 1 times x plus 1 squared. We're going to start by finding f prime of x so that we can use the first derivative test. So f prime of x, we're going to use the product rule. So we get the first x squared plus 1 times the derivative of the second. So we're going to do times 2 times x plus 1, and then we do 2 minus 1, so it's to the 1 power. Then we do the first times the derivative of the second plus the second, which is x plus 1 squared, times the derivative of the first, which is 2x. We can simplify this by factoring out an x plus 1 from the first part. So it's x plus 1 times 2x squared minus 1 plus 2x times x plus 1. We also know that to do the first derivative test, we have to know that f prime of x is also equal to 0. So then we set this equation equal to 0. So x plus 1 times our simplified out equation of 2x squared minus 2x squared minus 2 plus 2x squared plus 2x is equal to 0. We can factor out another 2. We have 2x plus 1 times x squared plus x minus 1, and I got that is also equal to 0, and I got that equation by combining like terms. Going back to continue to factor, we have 2x plus 1 2x plus 1 times 2x minus 1 times x plus 1 equals 0. Keep going, so we have 2x plus 1 squared times 2x minus 1, and then break these down into their individual parts. 2 can't equal to 0, so we disregard that. So we have x plus 1 equals 0, and 2x minus 1 equals 0. So x equals negative 1, and x equals negative 1/2. for x equals positive 1/2 because we've added a 1. Once we have the points, we need to continue, the critical points, we need to continue doing the first derivative test. So we're going to make a number line like this, and we're going to put -1, which was one critical point, and 1/2, which was the other critical point. And then we know that we'll have our f prime of x, which will help us to solve our f of x. So once we have, so we're going to put a value that is lower than -1, so say -2, and plug that in to our f prime of x equation, and we get a negative value. And then we're going to plug a value in between -1 and 1/2, say 0, which will give us another negative value. And then plug a value in that is greater than 1/2, say 1, and we get a positive value. If we are increasing or negative in f prime of x, we know that f of x is decreasing, again decreasing, and if it's positive, we know f of x is increasing. So then I like visuals, so I do a decreasing line, increasing line, and we know right here is a minimum value. Then we can say that f of x has a minimum at the point 1/2, comma, -27, -27 over 16. I got the y value here from plugging our critical point of 1/2 into the f of x to give us the y. So it's an input and an output. Now we know from our first derivative test that f of x does not have any maximum values. So we only have a minimum at 1/2. So 4x plus 1 plus, and then we can factor out a 2 here. So 2x squared plus x minus 1. And we can continue to simplify, and because we have 2 of the same, 2 times x plus 1, we can just cancel 1 out. So 2 times x plus 1 times 4x plus 1 times 2x minus 1. And then once that simplifies, we have 2 times x plus 1. We're going to start to do the second derivative test, then to find the point of inflection. So we need to find f double prime of x. So we're going to use the product rule again. So the first x plus 1 plus 1 times the derivative of the second, which is 8x plus x plus 2 plus the second 4 plus the second 4 x squared plus 2x minus 2 times the derivative of the first, which ends up being 1, so we can ignore that. we're going to continue. We can factor out a 2 from the second equation in this first part, so we get 2 times x plus 1 times 4x plus 1 plus factor this to get 2x minus 1 and x plus 1. And we have factored also out an extra 2. Because we have the same of these two x plus 1s right here, or 2 times this x plus 1, we can go ahead and group them. So we get this 2 times x plus 1, and then times 4x plus 1 times, or 4x plus 1 plus, make that a little clearer to write, plus 2x minus 1. So this breaks down to 2x plus 1 times 6x, which is equal to 12x times x plus 1. So then we also know, remember that f double prime of x is equal to 0, so we set this equation here equal to 0, and we get 12x times x plus 1 is equal to 0. So we get that x is equal to 0, or x is equal to -1. So now we're going to do the second derivative test, which means again we're going to make that same number line, and we're going to have the points that we just found, so -1 and 0. So we're going to first look at f double prime of x, so find a point around negative, or for -1, which is -2, and we get a negative, we get a positive, excuse me, and a point in between -1 and 0, so say -0.5, and we get a negative, and then a point above 0, say 1, we get a positive, and those numbers are found by plugging into f double prime of x. Then we're going to look at f of x now, because we have found the f double prime of x, so we're looking at f of x. So we have f of x now, because it's positive, we know it's concave up, and it's negative, it's concave down, and then it's positive, it's concave up again. So we know, because there was this shift in concavity here and here, and again here and here, that -1 gives us a POI, a point of inflection, and so does 0, we get a POI. So now we can say that f of x has POIs at, and then we have -1, plug that -1 into f of x to get this y value, which is 0, and another one at 0, comma, -1. And that is our final answer.